Greetings, this is M squared, and we're going to solve some rational equations. Rational equations are, again, equations that have fractions in them. That's what the word rational is going to be talking about, fractions. And you notice in our first equation, we have one fraction on one side and one fraction on the other side. So although the rule is when you have rational equations that you find the common denominator and that you multiply every term by the common denominator, if you have a proportion, which means one fraction equals another fraction, it's easiest probably to cross multiply. So we're going to cross multiply on this one. We get 5x equals x minus 3, because x minus 3 times 1 is just x minus 3. So when we minus x from both sides, we get 4x equals negative 3. And when we divide both sides by 4, we get x equals negative 3/4. And you could also say 0.75, negative 0.75. And if you want to check that, it's always a good idea to check. You can say negative 3/4 over negative 3/4 minus 3. Well, negative 3, you can use a common denominator here and get that worked out, or you can remember complex fractions, which I don't know if you've done yet, but let me tell you about it if you haven't. When you have a fraction in a fraction, the way to do that is to find the common denominator and multiply each term by the common denominator. So we multiply by 4 up here and 4 down here. And remember, if we multiply by 4 divided by 4, that's a number 1. We're really not changing the expression, we're just changing how it looks. So when I multiply 4 up here, I get a negative 3. When I multiply by 4 down here, I get a negative 3 minus 12. Well, what is negative 3 minus 12? Negative 3 minus 12 is negative 15. And 3 goes into 15 5 times. And the negatives cancel each other out. So it's 1/5, which is what it says it equals. So you could have also checked it with a 0.75, negative 0.75 in your calculator, and you would have gotten 0.2 equals 1/5, but 0.2 does equal 1/5, so you're fine there. So now we move on to another one that doesn't just have a fraction equal to another fraction. It has 3 fractions, 2 on one side, 1 on the other. And this time we're going to use our rule. We're going to find a common denominator. We're going to multiply each term by the common denominator. Well, the x's are in common, the 5 isn't, so we have to multiply the 5 times the x, and 5x becomes our common denominator. So we multiply each term by our common denominator. And then we cancel. Always don't actually multiply first, cancel first, otherwise it gets too messy. So we cancel our x's, and we get 5 times 5 is 25. We cancel our 5's, because 5 divided by 5 is 1. 3 times x is 3x. We cancel our x's, we get 2 times 5, which is 10. So now we have a linear equation. We need to get all the x's on one side, the numbers on the other side, so I minus 25 from both sides, and I get negative 15. And then if I divide both sides by 3, I get x equals negative 5. And you can check that on your own if you'd like. Down here, it looks like these are almost the same. But before you say, oh, they're in common, I don't really need to do anything, I can add. Let's just imagine I had 7 plus 2 and 7 minus 2. So see how it's 2, 3x, 2, 3x, and the difference is a plus and a minus? Well, 7 plus 2 is 9. 7 minus 2 is 5. Is there anything in common between 9 and 5? No, no common factors. So we can't think that those are common, because they're not. Now, notice there's 2 fractions on one side and 0 on the other side. So it would be possible to move that whole fraction over and use our cross multiplication again, or we could just multiply by the common denominator, which is this times this, because if you had 9 and 5 as denominators, you'd multiply them together and say the common denominator was 45. So if there's nothing in common between these two, then our common denominator is this times this. So we multiply both sides by 2 plus 3x and 2 minus 3x. So we do that with each term. Now when we multiply the right side by it, since it's times 0, it's just 0. So we don't have to go through that again. So on this one, the 2x plus 3's cancel out, and I'm left with 1 times 2 minus 3x. And 1 times anything is itself, so that's just going to be 1 minus 3x. This cancels with this, and I'm left with 2 times 2 plus 3x. So I need to use my distributive property. So I get 4 plus 6x. And so these are in common. That gets me a 6. These are in common, and that gets me a 3x. So I need to get x alone. I'm minus 6 from both sides. 3x equals negative 6. Divide 3 both sides. X equals negative 2. And that is the answer. If you had cross multiplied, you could have, if you want to see this, you could have said 1 over 2 plus 3x equals negative 2 over 2 minus 3x. It changes to a negative 2 because when you bring that over, it's negative. And I think it's easier to have a negative in the top than out in front. Same thing though. If you want to have a negative out here or a negative in here, just one of them negative. So then we cross multiply, we get negative 2x. Sorry, we get negative 2 times 2 plus 3x, is this times this, equals 2 minus 3x. Then we'd say negative 4 minus 6x, excuse my mistakes. And then we'd get all the x's on one side, so we'd add 6x to both sides, minus 2 from both sides. So we get a negative 6 equals 3x. And we divide both sides by 3, and we'd still get x equals negative 2. So either way works, whichever way you like better, but that, again, you can only do that if you have two fractions. Either on opposite sides you can do the cross multiplying, or you could have moved it over and done the cross multiplying, or you can use the rule that says when you multiply equations that have fractions, you first get rid of the fractions, so you multiply every term by the common denominator. M squared, signing out.